Hello, my name is Liao Xiuya, and this is presentation for Statistic Group project prepared for proof media Dr. Azura. And this is our team, Liao Xiuya, Osama, Rizki, and Omar. This slide about the project includes five parts. They are introduction, dataset, data analysis, conclusion, and reference. The first part is introduction about our project named Breast Cancer Case Study. The second most common cancer in women is breast cancer. It causes most female cancer deaths worldwide and is growing worldwide. Statistical analysis is needed to analyze tumor features and detect breast cancer early. Statistics demonstrate several tumor patterns. These findings enhance disease diagnosis and treatment regimes. This study examined breast cancer tumor features to find early detection markers. And there are some informations about our dataset. It's used to represent the frequency of different results in the data. It includes more than 300 benign diseases and more than 200 malignant cases. In data cleaning and preparation, we find and replace missing data and duplicate data. Our dataset includes more than 500 rows and more than 30 columns.
This is part of the data cleaning process. From these figures, we can see that check missing values. After we found the missing values, and then we can replacing the missing value with the mean, and then we processing with the checking the duplicate data. And the last one, we will see that the size of data is around 569 rows and also 32 columns. After we do the data cleaning, and then we can see that the structure of data here and also the sums of the summary data. Okay, now we talk about the data analysis. From this figure, we can see that there is two chart. Exactly, this is about the diagnosis P chart and also distribution of diagnosis. And this is also the part of data analysis. We can using the stem and leaf of concave points of mean. The concave point of mean measures that the average number of concave areas in breast cancer cell nucleus. This is also the part of data analysis. We can see that there is two graph here about the histogram of radius. The histogram of radius mean and radius words illustrate the rates Q and distribution. Illustrated that most of the cell nuclei in the dataset had smaller average radius.
So moving to the outlier analysis. So basically, there are two box plots. So the box plot indicate the comparison between the parameter length of the cell nucleus. So both box plots show the presence of the outliers and indicate there are some cell nuclei exhibiting a large boundary length compared to other. Besides that, the parameter words value were higher than the parameter mean, demonstrating the measurement of worst case were significantly larger than the average measurement. So basically, here are the outliers for both parameter mean and parameter worth. And next, we analyze the central tendency of various features to understand the general distribution of cell properties in Meninger and Began cases. So then next we moving to the hypothesis test. So basically we have two samples to be tested. So a t-test was conducted to compare the area mean of cell nuclei between Medellin and Began sample. The result was show a statistically significant difference, indicating that Medellin cell tend to have a large area mean than the Began sample. So, and we also perform a goodness of fit test to compare the radius mean of cell nuclear. The results suggest a statistically significant difference, reinforcing that malignant and began sample have a distinct radius characteristic.
And here is the chi-square test compare the parameter mean of a cell nucleus between the malignant and benign breast cancer. The null hypothesis stated no difference, while the alternative suggested otherwise. The p-value filled the critical region, indicating a significant difference between the two groups. And for the absolute correlation analysis showed a strong positive correlation, which is 0.29, between the concave points and concavity, indicating that increase in the concave point corresponding to the increase of the concavity. And for the regression, the high correlation suggested a strong relationship between the area rust and the radius rust, enhancing the prediction accuracy. The regression equation indicates that the area rust increasing by 115.92 for each unit, increasing in radius of rest. And lastly, for an ANOVA test, compared concave points across diagnosis group, yielding of a f-value of 861.7 and the p-value below the significant level. The large F statistic indicates greater variability between malignant and benign groups than within them, and the small p-value confirmed the significant difference in concave point mean. Finally, the final analysis highlighted the key factors distinguishing malignant from benign breast cancer. Intermediate measure linked to benign cases, while rust value indicate malignancy reflecting aggressive tumor growth. The study emphasized data preparation, feature selection, and statistical analysis, and in the detecting malignancy, recognize malignant and benign cell nuclei, can enhancing patient outcome and personalized treatment. This is all for my group. Thank you for watching.